We're trying to relate how the tectonic structure of the Earth creates different biological habitat zones.
The Mariana Back-Arc is where the upper plate here is spreading. So the part to the right is moving to the right, part to the left is moving to the left, causing the hydrothermal vents.
The challenge is in trying to understand a system so sparsely sampled and so completely out of view. The models that are out there are developed from environments that are just fundamentally different than the ones we're studying.
If these dives are successful, we'll really fill in a big gap.
Wish us luck. Knock on wood.
The animals, the microbes, they're not just living on hot seawater. They're really extracting the chemical energy that comes out. The quality of the chemical energy depends on what the reaction zone is underneath.
The dive went great. I mean, the very first science dive for this ROV, I thought it was fantastic.
I'm super proud of SuBastian, right? So this has been a long time coming, and now to see it actually bring up some samples and scientists with smiles on their face.
We want to look at differences in these really acidic arc volcanoes like this one versus the more neutral pH, deeper Back-Arc vent sites.
It's always good to come back to a black smoker, especially a giant one that we've never seen before.
You know, you go up with the ROV and they just keep going up and further and further. 30 meters, 100 feet tall. That's just crazy.
And these things are just pumping so much into the ocean. It blows me away.
Temperatures of those vents are above 300 degrees Celsius, which is pretty hot.
And you know, just centimeters away from that hot fluid, there's those crazy shrimp and worms and snails and crabs.
We were able to focus in on 2 crabs, and what we observed was something I didn't really expect. We've got one crab that is letting a larger crab, which is a very aggressive species, pick something from its shell. It's not moving away. So that might indicate that this is something positive for that crab. Then we have the crab that's eating something. Is this a regular food source, or is this something else? Could it be a grooming behavior? We don't know. And so what this kind of observation inspires then is questions that we can then think about testing.
Even though the animals are just gorgeous, we're not seeing as many as we might see at chimneys on another vent system. And it has something to do with the amount of fluid that's coming out through the sides of the chimneys. So that was a little bit surprising to me. Even though there's thousands and thousands of animals on the chimney, it's still possible to create more biomass, more animals, if you can channel more and more fluid through the chimneys.
I've never seen anything like this before as far as the morphology of the chimneys. The minerals that make up that chimney are not very permeable. They're really stuck into narrow channels, and their only choice is to go up. They can't go out. And I don't know the answer to that. The hardest part about chimneys is getting them. I feel lucky that I get to have these samples and look at them so we can learn about how long has this whole general area been hydrothermally active.
What we've done here is that we're not just looking at temperature. We're now pairing that with the fluid chemistry as well as oxygen as well as pH. And so we're going to be able to look at all 4 of these factors.
That imagery is telling us exactly the spots these animals want to live. The animals living in the Back-Arc are very different from the animals living on the volcanic arc, and we wanted to confirm that. We know that now.
The 2 environments are right next to each other, where the animals could overlap if they wanted to, but they don't. So that's really telling us a very clear message.
Geological setting is really important, probably influencing the chemistry and the microbes, and therefore controlling the animals.
And that really, I think, will help us understand the distribution of hydrothermal vent animals around the whole planet.
It just feels like a real privilege to come out here and do this kind of work. It makes me feel pretty good about society in that we are willing to put together the resources to come out and do things like this so that we can learn more about our planet.
What we've learned from work that we've done in extreme environments might help us to understand what might be the traits for species that are going to persist in a global ocean that is going to be changing markedly.